Hi, this is Geometry Lesson 1-7, talking about some different triangle properties. So the very first one that we start with is probably something you are familiar with already, and that is the idea that the sum of the angle measures of a triangle add up to 180 degrees. So if we take angle A, B, and C and add them together, we should land just at that. All right. So putting that to use in some questions where we've kind of seen some of these are, a ratio question. Saying if the ratio of three angles of a triangle are in the ratio of 1 to 3 to 5, find the measure of the three angles. We talked earlier when you have a ratio question, easiest thing to do is tag in an x or multiply an x because it's a multiple of 1, 3, and 5, not necessarily 1, 3, and 5 themselves. If you want to draw a diagram, go ahead. Don't worry about drawing it to scale. I tend to draw the same triangle regardless of the setup, but up to you. From here, what I really care about is that you understand how to put it together as an equation. So add up 1x, 3x, 5x. That's going to give us a total of 9x equals 180. You can mental math it or grab your calculator. X comes out as 20. Find the measure of all three angles. So for all three angles, the smallest is 20. The middle one would be 60. All right, and then the largest angle comes out as 100. And if we click double check, 20 and 60 is 80 plus 100. That would give us 180 right there, and we're good to go. All right. You might be given ones where it's a little simpler. There's no x's in there. You're just using that general concept, right? So you want to look at where do you have triangles? Where do you maybe have linear pair, things like that. So for number 2, it says find the measure of each of the following angles. Keep in mind that 12 degrees is referencing this angle right here. 62 is this guy. 40 is that guy. All right, so angle XYZ. XYZ, that's this angle right here. So I would focus on the fact that you have this triangle, XYZ, where the angles are all going to add to 180. So that would be my thought for that first angle. So you would be looking at 180 and then minus the 40 and 62 that are already there. So 40 and 62 would give me 102. And then subtract that, we're left with 78. All right, for angle WXY, this one, I wouldn't really use a triangle property. I use the fact that 62 and the angle we're looking for form a nice straight line. So because they are a linear pair, they are also supplementary. So if I go 180 minus 62, that's going to leave us with 118 degrees. All right, and then if we use that in conjunction with the 12 degrees here, we could focus on this skinny little triangle. You could choose to focus on the big triangle, WYZ, and use the 180 property there, up to you. Otherwise, I would have 12 plus 118, and then I'd be subtracting that from 180. So it'd be 180 minus, that should give me 130 degrees, and that's going to leave us with a 50-degree angle down in that corner right there. Teeny tiny, squeezing it in. So I'll zoom in just a little bit so you can see all of that. All right. When you're ready, go ahead and flip it on over to the next page there. On the next page, what we are looking at is we actually have our first little introduction to what a geometry proof looks like. Now, we're going to spend an entire unit, actually probably multiple units by the time the year ends, focused on geometry proofs, which means you're going to be proving different mathematical ideas, right, by using definitions and things that we know in geometry. So the first one saying, prove the triangle sum theorem. The word theorem, this just means it's something that can be proved. Okay. So you have triangle ABC, and then we've got the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. We're trying to prove that. So we set it on the first page, but we want to prove that it's actually true here. All right. So we are missing one other given. So when we look at proofs, you have to be given information to work with. The other thing that should actually be given here is that line L is parallel to line AC. That's going to be important to our argument here. And to show parallel, we can put the little arrow on it. So those lines are going to be parallel here. All right. So within a proof, we number our steps to keep our argument organized. Sorry, I was trying to think of the right word there. All right. Let me turn that a little crooked. All right. So the first thing, you actually start with your givens. So tell me what information we know. So we know we have triangle ABC and that we have line L that's parallel to segment AC. So over here, for the reason we state that it's given to us. All right. Then we want to think about what can we say from here? All right. Well, angles 4, 2, and 5 all create this straight line, which means they have to add up to 180 degrees. So we're going to state that next. We're going to say that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. Right? And instead of calling it a linear pair, since there's 3 angles, I'm going to call that a linear triple, just to make it more appropriate. So a linear triple means that we have a sum of 180 degrees, or they are supplementary. All right, here's where we get to use some angle properties. Right? If these lines are parallel, you can start to see these Z shapes being formed. If I see a little Z shape in the corners of the Z, those are alternate interior angles. So what that means is it means that the measure of angle 4 is equal to the measure of angle 1. And then I actually have a little bit of a backwards Z shape going on over here. And that means angle 5 and angle 3, those are also alternate interiors. So the measure of angle 5 is equal to the measure of angle 3. Now I'm going to put those both in step 3 because I have the same reason for both. What we're going to say is the fact that we have parallel lines, which we knew back here, that implies that alternate interior angles are going to be equal. Or you can say equal alternate interior angles. All right. Here's where we turn this into the step that we want. We want to say that angles 1, 2, and 3 give us 180. Right now, we know that 4, 2, and 5 give us 180, but we're going to do a little substitution here. If 4 is the same as 1, in place of angle 4, we're going to put angle 1. And if 5 is the same as 3, then in place of angle 5, we're going to put in angle 3. So let's do some substitution. So in place of 4, we put angle 1. We're not subbing anything in place of angle 2. Keep that. And then in place of angle 5, we're going to put in angle 3. So by subbing this in here and subbing that in there, we've actually proven what we wanted. We finished with the fact that those 3 angles add up to 180 degrees. So when we do more proofs in the future, we'll always take whatever's given to us. And then our goal is to finish with that prove step. So there's a little intro to what that will look like in the future. All right. The next thing we talk about is the exterior angle theorem. So that term theorem, again, means that we can prove it. Don't be surprised if we take a look at that in a little bit. So what we have here is that the sum of what are called the remote interior angles the sum of the remote interior angles is equal to the exterior angle. All right, let's think about what that means. First of all, remote interior angles. Here's the exterior angle. When we say exterior, we mean on the outside. So let's show where that is. So that's angle 4 in this picture. This would be the angle on the outside or the exterior angle. The remote interior angles. Well, there's 3 angles on the interior of the triangle. They're the 2 that are not adjacent to the exterior angle. So these 2 over here, these are referred to as the remote interior angles. So what does it mean in a little bit of a simpler terms? If I add up angles 1 and 2, it will be equal to the measure of angle 4. Every time, which is kind of cool. And we can prove it. Right? Before we look at a proof for it, though, let's just do some quick practice with it. So go ahead and flip on over to the next page here. We're going to do 2 of these 4 little examples right here. So using the exterior angle theorem, the first one is super straightforward. You've got the 2 interior angles right here, 60 and 70. And we want to use those to find the measure of that exterior angle x. So in this case, it is as simple as just saying add up the 2 remote interiors should be equal to that exterior. So that's 130 degrees right there. Done. If we jump down to the one below it to C, in this case, similar kind of setup. This time the remote interior angles are x and 82. So we can say x plus 82 should be equal to the exterior angle right here of 117. And just because of where the x is, now we can subtract 82 over. So calculator, if you got it handy, super helpful. All right, 117 and then minus 82. And there we go. There's 35 degrees right there. All right, so should the interior angles here be smaller than this guy out here? Yeah, absolutely. All right. We'll say B and D for some review in class. So when we slide down to the bottom, and it asks you to find the measure of angle GJH. So GJH means in the end, I want that little angle right there. All right. So in this case, remote interiors. Well, if here's my exterior angle, then my remote interiors are these 2 guys over here. So let's set it up. So what we should have here, let me zoom in just a touch so you can hopefully see a little bit better. Sometimes it focuses well, sometimes it doesn't. Is we should have 6x minus 1 plus 5x plus 17 equals 126 degrees. So go ahead and combine your like terms. 6x and 5x should be 11x. Plus 17 and minus 1 will be plus 16. And then we can keep on rolling. Subtract 16 on over. We get 11x and then equals 110. Divide by 11. We come out with x equals 10. And then don't forget, plug back in. So if we want the measure of angle GJH, it's 5 times 10 plus 17. That right there should be 50 and 17, so 67 degrees. Think about what numbers you shouldn't get. We shouldn't be getting negative numbers. We shouldn't be getting 0. Decimals, that's perfectly fine. If you get a really weird decimal, maybe double check your algebra, but shouldn't be getting anything bigger than that exterior angle either. On to the last page. All right. On the last page, it says prove the exterior angle theorem. All right. We are going to start this, and I'm thinking we will take some time in class to finish it. So to prove it, this one, I don't have to sneak in any extra givens for you. There's one given. That's the fact that we have triangle ABC here, and we can write over here that it is given to us. And then we're actually going to start with the last thing that we proved, and that is the triangle sum theorem. So we're going to say that the measure of angle 1 plus the measure of angle 2 plus this guy over here, the measure of angle 3, is equal to 180 degrees. And that is called the triangle sum theorem. From there, we have 3 more steps. So label them right now. 3, 4, 5. 3, 4, 5. And we're going to pick back up with that tomorrow in class. So if you are somebody who's not with me in person. You might want to check in to class via Google Meet to get the last of those notes in there. Don't forget to answer the post video question. Thanks, guys. Have a good one.